Hello, my name is Edgin Montiel, and this video is for Dr. Christopher Foley's 1503 Introduction to Engineering Design. This video is going to be going over the SOLIDWORKs Stress Analysis tutorial. So I already got SOLIDWORKs open. This is version 2023. I click on the Help button, go down to Tutorials. This time we're going to go to this Design Evaluation tab, and we're going to do the SOLIDWORKs Simulation Xpress tutorial. So inside this one, there's 6 different parts that we are going to be doing various analysis on, and I'm going to show you the deliverables for Dr. Foley's assignment along the way. So this one's a little bit different than what we've seen before. So this tutorial is broken down into 3 parts because it's a little bit longer than some of the other ones. So this is just so you can kind of pick up where you left off a little faster with these hyperlinks here at the beginning. But we're going to go ahead and start with the very first one, which is basic functionality. And we're going to go ahead and work with this hook. So we're going to go ahead and hit next topic. So now I'm finally at the part in the instructions where you can download the hook file. So you actually don't have to make the hook because we're just going to do an analysis, the stress analysis of this hook, of this particular part. So you could either click here and download it from your SOLIDWORKs, or if you are enrolled at UCCS and part of Dr. Christopher Foley's class, under the assignment in Canvas on Lab 7 Stress Analysis, you can actually download the parts here. So I can click on this little download button. It's going to come to my download folder. I can open up that folder, and just like before, it's a zipped file, so I can right-click on that, and I can hit extract all of them, make sure I understand where I'm extracting them, because then I can open up all these parts from Dr. Foley's download in Canvas. So these are the same parts that we're going to be doing in SOLIDWORKs, so I'm just going to go ahead and load one of these, because we're going to start with the hook. So now I got the hook loaded, which would have been the same thing if I can click here and download the part or open it up from inside SOLIDWORKs file system here. So now it wants us to do some various things. So on here, I think I already have my setting off. So some people, if you go to this Evaluate tab, and then here's my Simulation Xpress button, you have these 2 little arrows over here to the right. Sometimes, depending on the resolution of your screen, you may not be able to have all these buttons. See how when my window's smaller, my button disappeared now? So there's these 2 little arrows right here that I can use my left click and click on that, and it's going to give me access to the rest of the buttons that SOLIDWORKs is hiding, just because I don't have room on my window right now. So SOLIDWORKs has a million buttons, and not even all of them are displayed for us right now. It feels like there's a ton of buttons that we're looking at, but this isn't even all of them. So they have to cram them in here somehow. So you could either access the Simulation Xpress by going to your Evaluate tab and coming way over to the right and finding it here, or you can always type in this little search bar up here. You can type in Simulation Xpress and you can find it right there. Or alternatively, the last way is you can come up here to Tools. So remember, if you don't see these words up here, that you just have to go to that little arrow and you can make them appear. You can go to Tools and use Express Products and find Simulation Xpress here. So SOLIDWORKs has a lot of different ways that you can get to the same thing. It makes it really convenient. Depending on how your memory works, you might remember one of them, but it's a little overdone, right? There's 3 different ways to do the exact same thing. They should almost just stick to one. But anyway, so I'm going to hit this button, and mine worked right away. So sometimes when you do this, especially if you're doing it the first time, I'm going to go ahead and exit out of this, that it may give you this error message, and you have to hit OK. But what it's wanting you to do is you have to come up here to, I believe it was the Tools menu. You're going to have to scroll all the way down and find this Add-ins button, because if you have this little box checked right here, it actually won't let you use that Simulation Xpress tool. So let's see if I can replicate what it would look like. Come on, SOLIDWORKs, what you doing? I made it mad. There we go. So right here, you see I got this error message where it was blocking you. So if you got this same error message right here, that you weren't able to launch the Simulation Xpress, that just means you need to come up here to the Tools, come down to Add-ins, and uncheck this little box here. You can also check this box here as well. This will ensure that it is not checked on startup. But I found, in my own opinion, I don't know if this always works. So you'll have to play with your SOLIDWORKs. I haven't messed with it enough to really say it 100% works or not. This is the student edition, so it is what it is. So just make sure it's unchecked here so that I can actually launch it here. And now my SOLIDWORKs is loading. There it goes. All right, so now once we're in here, we're going to go to our options. And the first thing it wants us to do in the tutorial is to make sure it's set to English units, so you only have SI or English. And then make sure you know where it's saving. So I am actually going to put this on my desktop, and I'm going to make a new folder. Oops. New folder called Stress Lab. I already have one called Stress Lab. So we'll just use this new folder, because I've done this before. I had to practice before I made this video. So I'm saving it on my desktop in a folder called New Folder. So I select that folder as to where I want to save everything that I'm going to be doing here, and then make sure that this little box is checked, is what the instructions say. Then hit OK, and hit Next Topic. Now it wants us to add a fixture. So right now we are in our SOLIDWORKs Simulation Xpress add-on. So over here to the left, we still have our design tree, like we're used to seeing. And over here to the right now, we actually have the Simulation Xpress. So that's how I got into that options that first window was talking about. And then we want to hit Next, because that's what it said to do. And now you can see I have numbers 1 through 6. We're on number 1, where we want to add a fixture. So this is where we're actually going to hold the item in place. Because when we're doing stress testing, we have to be able to hold it in place somehow, like designate a rigid spot of the object that we're stress testing. And then we're going to have to apply a load somewhere to actually see what happens when we're loading it up, to see if it bends or breaks or what's going to happen. So you'll get to see all that. So the first thing we got to do is add a fixture, which is where we're going to actually make this thing rigid, where we're attaching it somewhere we don't want it to break. So I click this Add Feature or Add a Fixture button. And over here to the left, just like we're used to, we get a Property Manager for the fixture. And right here, you can see that this blue box is already selected because it's ready for me to populate the features that I want to put. So the instructions tell me to pick this inner cylinder shape here. So I click on that, and it adds face 1 over here. So then I go ahead and hit check mark, and over here in my history of what I've done here, I can see under fixtures, I have it fixed right here. So that just means it's holding it in place, and that no matter what I do to this hook, whatever I tell SOLIDWORKS, what kind of loads I'm loading it up with, that it's just going to stay put right there. So I'm done adding my fixtures, so then I hit Next, and now we want to add a force. So I hit Add Force, and now that I add force, exact same thing. Over here to my left, I have my Property Manager window for the force, and I'm already selected in this blue box because I need to decide where I'm going to add the force. And if you look at the SOLIDWORKS tutorial, it's going to tell me see if I can manipulate this. So it wants to make sure you understand that you're picking 2 different faces, because we want to put the load across the top of the hook, which makes sense, because if we had this hook hooked somewhere, like hanging on a rope, and we wanted to hang something from it, then it would actually be filling the effects of whatever's hanging on it right here on these 2 faces. So under where the force is going to be applied, we want to pick these 2 faces in SOLIDWORKS. So there's face number 1, and here's going to be face number 2. Then, under the selected directions, we want to make sure we check that option. And then it's going to give us another box to populate, and we need to pick plane 2. So remember, whenever this Property Manager is open, it forces our design tree over here to the right. So we have to access our design tree over here, and this is where we can find our different planes again. And when I hover over plane 2, I can see that's the one that makes sense. So we're going to try to orient our force application that's related to this plane number 2. As you can see, it's already made quite a difference because they're all pointing straight up now, when as before we were normal to it. So normal just means that at any point on here, you're perpendicular to it. So that's why they kind of follow the curve around, which doesn't make a whole lot of sense because that's not how the force would be applied. This one's not perfect either, but it's closer. So we're going to say that these 2 surfaces are filling the force, and right now it says the force is going up, which doesn't make sense. So we actually have to hit this little reverse direction button because the force would be going downwards on it. And then here we have to enter the value of the force. So this part is very important in SOLIDWORKS as well, because again, you have to understand what we're telling the computer to do. So we're telling it that on face 1, we want from this plane number 2 direction, so coming straight down, perpendicular from plane number 2, it's going to apply 1,500 pounds of force on each one of these. So the way I have this set up right now, even though this value says 1,500, it's actually applying 3,000 pounds of force on the hook itself. This reads that I'm applying 1,500 pounds of force per face selected. So that means if I'm talking about the hook in general, it's 3,000 pounds of force. But if I'm talking about a particular face, the way that SOLIDWORKS wants me to talk about it, it's only 1,500 pounds of force per face. So I hope that makes sense to you. I'm going to go ahead and hit check mark because we are done with that. Now we're going to go ahead and hit next and go into our material, because now we want to choose a material. So I click on this choose material button, and I'm just going to glance at these instructions again because I want to make sure I am not missing anything here. And it's going to want us to make it alloy steel. So under SOLIDWORKS, when we click that choose material button, SOLIDWORKS has a whole library of materials here. So I can open up this material. Underneath there, there's steel. And they're all in alphabetical order, so I look for alloy steel. This is already all pre-filled out for me with all the material properties that this particular alloy steel has, so I can hit apply. And then you can see it change color in the background there, because now it's no longer a material-less object, because before there was no material assigned to it, so SOLIDWORKS didn't know what it was material-less. So now it actually has material. We know that it's an alloy steel, and SOLIDWORKS has applied all of these material properties to it. So I can close that window now, and just to make sure I got it right, it lists everything over here, just to cross-reference the two major material properties that it's using in its calculations here. So then I hit next, and it actually wants me to go ahead and run the simulation. So I click run simulation, and my computer is going to do what we pay it to do, and it does all the hard work of the calculations and simulations so that we can see an animation of what's going on here. And it does this little jiggly motion here. So that's what would happen if we actually loaded this up. So again, we're holding it still here. So imagine this is on like a rope or something hanging, and we're putting a load on this, and the heavier the load gets, the hook is going to start to bend in that direction that it's showing there. And it's just going back and forth. So obviously it wouldn't bend upwards. It would be bending downwards. So I can hit the stop animation button over here to the right. And then does the part perform as you expect? I can say yes, continue. So now we can talk about these three different options that are here in SOLIDWORKS. So the first one up here at the top is the actual stress representation in a pictorial graph form here. So everywhere you see blue is where this material is feeling the least amount of stress. And stress is actually a calculatable value that we come up with to describe the forces that are happening inside of the material between the particles. So when you add a load to an object like this, the molecules, the particles that make up the material, are still all bonded together, and they're trying to hold together. And as we're loading it up, those bonds are actually going to start to feel the force that they're trying to be pulled apart because we're adding force on it. And they're going to feel it in a very particular way. So doing this stress analysis, we can tell that by loading this up with force, as we apply a heavier and heavier a load to it, the molecules are the part of the material that's going to be the most stressed, the part that's the angriest, that's getting ready to fall apart the quickest, is right here. And that makes the most sense, because if this was real and it was a metal hook, you could imagine that if we put a bunch of weight on it right here and held it perfectly still up here at this rigid point, that it would actually start to bend right here at this elbow. So that's actually where it's feeling the most stress inside of the object itself. So this graph actually makes a lot of sense, because this is going to be the highest point of stress concentration. And there's not anything over here. This is all very light blue because it's not stressed out at all. This one doesn't feel any of the weight because it's not attached to anything. So this graph makes a lot of sense, and it gives us a lot of information about what's going on with the part, and models it for us and does all the math, and we don't have to do any of this hard calculations ourselves, because wait till you get to like your junior and senior years where you take some of these classes where you have to do this by hand, and it's very complicated. So that's all something called stress, and that's really nothing that we need for this assignment. I just want you guys to start to understand what it is, because it is going to be very prevalent in our mechanical and aerospace engineering paths as we go through school. So the next one is show displacement. This one, oh wait, before I go there, I actually want to show you we can play the animation while we're evaluating the stresses here. So you could just see as we're adding the force, as it moves from its original location, where it's all pretty in blue, then it starts developing the stress concentration right here where we expect it to, when it reaches that maximum load capacity where it would ultimately break. And then we could stop that animation, and we can go to show displacement. Now this one's displacement. So again, if we're holding this perfectly still, it makes sense that this is blue and that it's not moving at all. Computers wig out when it gets 0, right? So it's hard for it to calculate 0. So that's why it's 3.937 times 10 to the negative 32. That's a super tiny number. It's pretty much 0. So what the computer is trying to tell us is that this isn't moving at all once we apply a load to it, which we told it not to move from this point, so it makes sense that none of this is moving. When we apply the load is being applied down here, so the maximum movement makes sense that this is going to be the highest displacement by the end of this, because when we load this up, it's going to bend downwards, meaning that this part is going to move the most, and then it ultimately will snap right here. So we can play the animation on this one as well. So you can see where it's showing us where the displacement is actually taking place. So this gives us a lot of information. You can imagine on a more complex part, this definitely makes your life a lot easier, especially since we don't have to do all this math by hand. So I can hit the stop animation on that. So then I want to talk about factor of safety. So the factor of safety on this one is calculated by our input of the force. So we said that we were putting this 15,000 or 1,500 pounds of force on each face here, so a total of 3,000 pounds of force. And based on that input, SOLIDWORKS gave us a factor of safety of 7.59716. So what that means is that I would have to multiply my 3,000 pounds of force times 7.59176 for this hook to reach that maximum stress level and for it to break. So the way that I described it right now, it can actually hold 7.6 times the amount of weight that I described to SOLIDWORKS. So that's what the factor of safety is. So to understand the maximum weight, the maximum force that this can withstand, all I have to do is take my input, which is, remember, it says per face, so my 3,000 pounds of force times the factor of safety SOLIDWORKS gave me, and that's going to give me the total amount of force that my hook can withstand. Now that I want to apply a factor of safety, whatever that factor of safety may be, if I want it to be a factor of safety of 2 or 3, I divide my maximum force the part can withstand divided by that factor of safety, and that's the force with that factor of safety. So I believe some of the instructions talk about that. Let's get back to there. So we already ran simulation. So it wants us to look at the mesh. Let's go back and take a look at that. How did I look at the mesh? Oops. So here's where it's talking about calculating the maximum force. So again, we did 1,500 pounds, the factor of safety of that, to each of the two faces. So it's worded weirdly here. You have to catch that the times 2 is right there. And then here's another way to look closer at the factor of safety. So completing Dr. Foley's assignment, this is where you can find definitions if you did understand my explanation of it. So then we can review the results. We already did that. All right, change settings. Where is that button? So we click on run, and then click on change settings, and then change mesh density. So it's going to delete the current study, so I just tell it OK. So now here is our mesh density. It usually shows it. I wonder why it doesn't show it on my screen right now. But we could either go for a coarse mesh or a finer mesh. So when it's doing this analysis, it actually puts a mesh over the entire object itself, and the tighter, the closer the mesh is, the more accurate its calculation is going to be. But the finer we make it, the more processing power that it takes, the more intense the calculation. So I believe the instructions wanted us to turn the mesh all the way up, if I remember right. To the rightmost position, and then hit check mark. Okay, so we're going to do that, and then we hit next, and we're going to run the simulation again. So this time it's doing it with a tighter mesh. It's going to do a more precise calculation. So it takes just a moment. I don't know why it yelled at me. And there it changed the factor of safety only slightly. So making it much more complex didn't really change it all that much, is the point of that. So you could do a much more complex study, but you could realize that ultimately it's only a 1% difference, is what the instructions were trying to show you. So you can make the math, 100 times harder than the complexity that we had already started with, because it's already a pretty tight mesh. Even when we use a coarse mesh, that's way more complex than we can do by hand. When we do it by hand, we're like cavemen. The computers definitely brought us forward a lot. So even using a coarse mesh on the computer actually provides a great understanding of what's going on inside the material as part of its stress and whatnot. So this is just letting you know that we can make the math a lot harder for the computer as well, and it's really only a 1% difference. So it's kind of up to you whether or not you use it. Worth it. And then I kind of already talked about all this stuff because I think it's just going into detail about how you can look at the different stress stuff. If you wanted more information about that, I recommend looking at these instructions because it goes into more depth. I may have missed something, so you could definitely look about the displacement as well. I think that one's a little more self-explanatory. And now we're going to generate the report. So I'm done reviewing results, and I have two options here. So I could either generate a report or generate e-drawing files. So I'm going to click on the report because this is the one that's actually required for Dr. Foley's assignment. So I want to start there. So when I generate the report, I can actually type in a description of more what's going on. I can actually write my conclusion to the report right here, because this report will generate all of the technical information, but it doesn't write any rhetoric for you or any of the subjective or opinionative or assumptions. So you actually have to do all that yourself. So you just need to make sure that you save this on your computer where you want to. And I had made my new folder on my desktop, so that's the one I want to save in. It's already there. And I can name the report whatever I want it to be, report of hook. And then I click generate, and SOLIDWORKS is actually going to just use all of its software and AI capability to generate, well, it's not really AI, just its software to be able to generate the report, because it's just pulling off all the common information into a template that is used to compiling there. And we'll be able to go look at the mesh, because I'm not sure why my computer didn't load that particular view of it with the mesh, but we'll be able to see it in this report, so I could talk a little bit about it, and you guys can visually see it while I talk about it. Just depending on your computer's processing power is how fast that's going to go. It also likes to use Word, so you're going to need to make sure you have Word installed on your computer. Otherwise, when it tries to launch this report, it's not going to do it right. It's just a docx.file, so I think you have to just have something that can open the file ultimately. But Word is what my computer has. So you can see it ultimately generated a report where it has a cover page. It tells you what's going on. Again, we didn't fill out any of the other details, so if you wanted to actually make this report for like your job, you could actually go in here and fill out these fields. And then here's the model information. It talks about how we loaded it and what it is, the volume. It's a solid body, because that's all we have is the part stuff. What was the material properties, loads and fixtures, where we fixed it, where we loaded it, how it was loaded. Here's the mesh information, the mesh details, and now here's the mesh complexity. So this is the more defined mesh, because this is the second time I ran it. So before, it wasn't as tightly meshed as this, and we got just as good as a calculation. So you can make it's super complex for your computer to make this mesh super tight, just like this, to make sure your geometry is awesome. And maybe if you're making something for space, you need to try to eliminate as much of the error as possible, so you do want the mesh to be this tight. But for normal application with a variable acceptance and quality and whatnot, what we're going for usually as mechanical engineers, the mesh doesn't usually have to be that tight. And then you have your stress analysis here, your displacement analysis, talking about the loading again, just reminding us. And then you can type in your conclusion here. So it's really awesome that SOLIDWORKS would generate the report for you, because especially if you are working in the professional field where you have to give detailed information about a part that you may be analyzing for a project that you're working on, or you're trying to develop a new component for some kind of design, you're definitely going to want to run it through vigorous analysis to make sure that you're using the proper materials. SOLIDWORKS can do so much more beyond this. There's this optimize thing that comes next, so I can hit next. I don't think this one of the tutorial wants us to do that yet. Did we close the report? So then, yay, you're done. We got to move on to the next one. So we're not actually going to optimize it yet. So we are just done with this part for now. For Dr. Foley's assignment, you just need to save this report, which it already saved for me. I'm just going to make sure that it did, because you guys will need to Had it in the new folder, and there it is, report a hook. So it's saved for me. So I am good to go with this one. And I'm already at 25 minutes on this video, so I think I am going to do, this was the longer part. This one's the longest one. So I think for the rest of the parts, I'm going to break that into another video. So thanks for watching, and I guess you guys will have to catch part 2.